So probabilities are the most common way that the likelihood of a certain event happening is expressed. Okay, but there is another way. It's called odds. All right, now odds are a little different than probability. First, we have to be a little more specific. We have to talk about either the odds in favor of an event or the odds against an event. Right, and the way we calculate these is the odds in favor are the number of positive outcomes to, right, that's how we would read that little ratio symbol in there, to the number of negative outcomes. And the odds against, it's just the other way around, right? If the odds against the number of negative outcomes comes first, and the number of positive outcomes comes second. All right, so let's look at some examples. Find the odds in favor of drawing a queen from a deck of cards. Okay. Well, what did our definition say? It said the number of ways to get what we wanted, the number of ways to draw a queen to the number of ways to draw, well, not a queen, right? To draw something else. Okay, well, how many queens are there in a deck of cards, right? There's one per suit, so there's 4. How many other cards are there? Well, it's 52 minus those 4, so that's 48. And again, we're going to leave it this way. We're going to leave it as a ratio, but we still should reduce it. So if I divide both of these by 4, I get 1 to 12, right? In other words, one card is a queen for every 12 cards that aren't. All right, so that's the first one here, right? Now, how about the second one? The second one, if you take a close look, the second one, just turned it around, right? I instead of saying the odds in favor, I said the odds against. Okay, what's the odds against? Well, that is the number of ways to not draw a queen to the number of ways you can draw a queen. Okay, well, the numbers here are really the same, aren't they? The number of ways to not draw a queen is still 48, and the number of ways to draw a queen is still 4. And if I reduce this again, I get 12 to 1. They just reversed. All right, they just reversed. That's really all the difference is. All right, so now let me give you one here. This is playing off of what we saw the last time in the last lecture, right? Remember, we're talking about the odds of a family with 3 children. Remember, there are 8 different possible ways for a family to have 3 children, right? 8 combinations of boys and girls. Okay, so there are 8 total possible family outcomes, and 3 have exactly 1 girl. The girl could be the first child, she could be the second child, or she could be the third child, right? 3 possibilities. So now you got to go back and look. Oh, that's for the odds in favor. All right, well, that's the number of ways to have a girl, the number of ways to have exactly 1 girl, to the number of ways to not have 1 girl. Well, if there's 8 altogether, and 3 of them are the 1 girl combinations, that leaves 5 to be, well, everything else. So there's my odds, 3 to 5. Okay, so odds versus probability. Okay, first, what we really want to be able to do, what we're going to do for the remainder of this lecture is look at how to go back and forth between the two. But fundamentally, right, what is the difference? Odds compare successes to failures where probabilities compare successes to the total. Right? That's the key difference. Right? Key difference between the two. So let's see how we could do some conversions here. If the probability of an event is 0.23, what are the odds against the event happening? Okay, well, I need to know successes versus total, right? Well, look, think of this 0.23 as 23 100ths. Okay, that means we got 23 successes out of a total 100 trials. All right, so I want the odds against the event happening. So that is failures, if you will. Success and failure are kind of technical terms in statistics. They don't have the good versus bad implication that they have in English. When I talk about a success, all that means is I got the thing I was looking for. When I talk about a failure, all that means is I did not get the thing I was looking for. Right? So I need failures to successes. All right, well, I know the number of successes. That was 23. Right, that's my numerator. Well, how many failures were there? Well, look, I did this experiment 100 times, and I got 23 successes. That means the number of failures must be everything else. So it's 100 minus 23, which is 77. So there's my odds. The probability of an event occurring is 0.23 is the same as odds against of 77 to 23. Okay, so how about going the other way? Right, the odds in favor of an event are 3 to 5. How can we turn that into a probability? Well, remember, right, I've got 3 to 5. This is successes, and this is failures. Okay, well, what I need to find the probability is successes divided by the total. Well, I know the successes already. That's 3, right? What's the total? Well, success and failure are the only two possible results, right? So if I got 3 successes and 5 failures, then the total must have been 3 plus 5, or 3/8. And that's it, right? There's my corresponding probability. Okay, so what's next? Now we've talked about some basic probability calculations, and we've really been focused on simple events, right? And an event that only has one possible acceptable result. Well, what about bigger events? Right, that's what we're going to focus on throughout really the rest of this chapter, is how we can calculate the probability of what are called compound events.